Good morning, students. In this video, we are going to see different modes of operation for encrypting arbitrary length of data. The previous classes, we saw the different encryption decryption algorithms. So in that encryption decryption algorithms, normally the block size is of fixed size. For example, we are seeing these algorithm where the block size is 64-bit block of data, ID algorithm, then AES algorithm. All the algorithms has a fixed size of blocks, but it is not possible to have the same block of data with fixed sizes. So sometimes you may get a message which of arbitrary length, which may not be exactly the size of the block. For example, you may get a message of 1000 bytes or 2000 bytes or 3000 bytes like that. So there should be some method to encrypt the arbitrary length of data. So NIST defines the different ways to do that, and they are termed as different modes of operations. And today we are going to see in detail about what are the different methods of encryption using the arbitrary length of data. Before going to that, we want to see a concept called as a message padding. What do you mean by message padding? Normally, the data is divided into different blocks, and the blocks are termed as P1, P2, P3. Since it is arbitrary length of data, the last block may not be exactly the whole block. So we need a concept called as a padding. Okay, for example, if the block size is 512 bits of data and your data is only 500, and we may be using another block. Okay, the 12 bits of data will be stored in another block, but remaining bits should be padded. So there are different methods for padding. One method is called as here, you are going to use a null value or zeros or sequence of ones or something like that. Or you can also use a concept called as to store the length of the pad bit. Or you can use to store the length of the plain text, or some other 2 or 3 methods combined together also can be used. Okay, but the problem is if we are using the padding bits and for storing the length as well as length of the padding bits and length of the plain text, sometimes you may need an extra block to store that information. Okay, so now we'll see in detail about the different modes of operations. There are basically 5 modes of operation that can be termed as ECB, what we call as electronic code boot mode. Another one is called as a cyber blockchaining mode, CBC, output feedback mode, OFB, cyber feedback mode, CFB, and counter mode, CTR. Out of which in this video, I'm going to explain about the first 2 modes of operation, ECB and CBC, where OFB and CFB is can be termed as a stream cipher, can be used for stream cipher. And in detail, we are going to see about ECB and CBC. In the later video, we'll be covering the OFB as well as CFB and the counter mode of operation. Okay, so there's 2 methods, out of which the first method was called as a ECB is a very, very simple method. Okay, so as informed earlier, the plain text is divided into broken into a number of blocks, and the blocks are termed as P1, P2, P3, and Pn. And normally we call this, there are n number of blocks, and in this method, each and every block is encrypted independently. So using the encryption key called as key. The formula what is given is the ciphertext is equal to encryption of plain text. If there are n block, the formula for ith block is the ciphertext of CI is equal to, you are going to give plain text input for the encryption algorithm using the key k. Okay, and for any given key, normally we are going to use the same key for all the encryption. For any given key, this mode behaves simply like a huge code book. So in where each and every plain text block has a corresponding entry of plain text as well as ciphertext. So only the name is given as an electronic code book. But though it is very simple, we have a lot of advantages and disadvantages. The diagram explains about the electronic output for encryption as well as decryption. What are the advantage and disadvantage of this ECB method? It is very simple. As informed earlier, we don't have anything to do. Already encryption algorithm is there, as well as we'll be having the simple method of plain text and cipher test. But the problem arises when same type of input is given as a plain text. Okay, for example, we have SSN number or order number. Sometimes what happens, we may repeat the same type of data repeatedly again and again. And when you are using the same key for encryption, the output of the encryption, the cipher test will be same if the input is same. Okay. So if the example what we given is SSN is sent twice, we will get the same cipher test for the same SSN number since the keys are same. This is the major disadvantage of ECB. So pattern matching can happen. So whoever wants to add the information on seeing the pattern of the information, they may be able to identify what type of information is being transmitted. So the major application of the ECB is to secure transmission of the small pieces of information, short pieces of information. For example, any key can be transmitted between the source and the destination. This is the ECB. Next, we go for the second method, the mode of operation, what we call as a CBC, cyber block chaining method. Similarly, like ECB, here also the plain text is divided into P1, P2, P3, and there are n blocks on the important of concept of cyber block chaining method is the plain text. Okay, for getting the cipher test for a plain text, it has to be XOR with the previous cipher test. So only the name what it called as a chaining method. Okay. For example, if there are n blocks, if you consider I plain test, the ith plain test is exclusive OR with the cipher test of I minus 1. Okay, Ci minus 1. Okay. So we have formula is given as the cipher test of Ci will depends upon the cipher test of Ci minus 1. Similarly, the cipher test of Cn depends upon the cipher test of Cn minus 1. And the decryption is also the same process. The only point you have to consider is what happens to the first block of data, because the first block of data will not have any cipher test. In the case, we are going to give a initial value IV. The initialization value is given as the input for that. So always C0 will be IV. IV, it is used to start the process. Okay. This diagram indicates how the cyber block chaining method functions. We can see we have n number of blocks. So we are given input as P1 and initialization vector is given, and you are going to encrypt using the key K, and you will be getting the output what we call as a C1. Similarly, for second block, we will be getting C2, C3. The only difference, you can see the diagram here, the C1, okay, is given as a input for the second block, okay, P2, okay. So P2 depends upon the C1, P3 depends upon the C2, like that. Pn depends upon the Cn minus 1. So one particular cipher test depends upon the previous all cipher test. So even if you have the same pattern of information as a plain test, the output will be, the output cipher test will definitely will be different. That is the major advantage of a cyber block chaining method. It depends on the what type of input you are going to give. Like our other method, ECB, here also decryption is a reverse process. Instead of plain test, you are going to give a cipher test as the input. Now, this is the detailed diagram of the CBC method for encryption as well as the decryption of the cipher test and plain test. Okay. What are the advantages and disadvantages of CBC method? Okay. So as informed you in the previous slides, the encryption of a particular block not only depends upon the previous one, but also it depends upon the previous all the blocks before it. So even though if you have a repeated plain test blocks of data, definitely the ciphertext will be different. And another one is we are using a transfer called as IV, initialization vector, in the beginning. Okay, this IV should be known to both sender as well as the receiver. Typically, the IV can be sent before in hand, before the starting the transmission, either using the ECB mode of transmission. Okay, so that is the advantage of this CBC method. Okay, so today we are seeing the two blocks of method, what you call as a UCB as well as CBC. And the next video, we'll see the other three modes of operations. Thank you.